This is Softwareable Bytes. Hello and welcome to a new episode of Softwareable Bytes. This is a show where I read to you from various blogs out there about subjects related to software and cloud engineering and architecture, site reliability engineering, DevOps, and everything in between. These are topics I'm passionate about, and if you are too, then this podcast is for you. In today's episode, I'm reading to you from CNCF, Cloud Native Computing Foundation blog, an article titled Gitops 101. What is it all about? Gitops 101. What is it all about? By Andrew Zola. This article is published on Cloud Native Computing Foundation, CNCF.io. This is a guest post originally published on Megalex's blog. If you think Getups sounds a bit like DevOps, you would be right. Getups is essentially an operational framework that uses DevOps best practices. In this scenario, we basically move all cloud operations to Git. Git is essentially a source code management (SCM) tool developed in 2005 to support software development projects. As Git is already a core part of application development, leveraging Git enforces DevOps best practices and provides access to a robust version control system. Other benefits include infrastructure automation, continuous integration, continuous delivery, CI/CD, and collaboration. What is Getups? Weaveworks coined the term Getups in 2017 to share the idea that all deployments should be as easy as enacting a code change. Getups is a standardized workflow for configuring, deploying, monitoring, managing, and updating infrastructure as code Kubernetes and all of its components as code. This includes all the applications that run on it. The core idea here is to have declarative descriptions of the infrastructure and all related elements in its currently desired state in the production environment. In this scenario, an automated process ensures that the described state in the repository and the production environment always match. In this case, it considers everything related to software deployment, code-based changes, build, packaging, application validation, infrastructure changes. Because of everything that was required, Kubernetes was the ecosystem of choice for GitOps projects. The Kubernetes platform is the perfect solution because of improved developer productivity, higher reliability, increased flexibility, enhanced operational flexibility, improved auditability, compliance, and security. As GitOps evolved, the definition of microservices also changed to accommodate more movement. As such, we are summarized GitOps as an operating model for cloud-native technologies and Kubernetes that comes with a set of best practices to achieve unified Git deployment, management, and monitoring for containerized applications and clusters. A pathway towards efficiently managing applications by applying Git workflows and end-to-end CI/CD pipelines to operations and development. At its most basic, GitOps is about merging intelligent source control with automated CI/CD tooling. For example, whenever you add some code into a Git repository, a lot happens to ensure that your code gets to a relevant target automatically. For example, if you have code for a new application feature, it automatically ends up in the existing application. Whenever your code declares a network policy update, it's automatically propagated into the network infrastructure. What are the GitOps principles? In a cloud-native environment, with Git as a single source of truth of the system's current desired state, you can commit all intended operations with a pull request. All changes are observable and auditable, and automatic conversions highlights all differences between the intended and observed states. Getups encompasses several guiding principles. These include the following. The entire system is in a declarative state. Getups demands an infrastructure that's always declarative. It should also concentrate on the target configuration. In other words, it focuses on the desired state and enables the system to execute whatever it needs to realize a desired state. In contrast, an imperative approach concentrates on a set of explicit commands to change the desired state. This makes reconciling a change as imperative infrastructure is unaware of the state. You must store the declarative state of the entire system in Git. In this case, Kubernetes is the most prolific declarative infrastructure that allows you to keep its state in Git. The canonical desired state versioned in Git. When it comes to Gitops, the canonical state is essentially the source of truth state. For example, when the state is stored and versioned in source control, it must be viewed as a source of truth. In this case, you can test objects on how equal they are when compared to canonical form. Whenever there is a deviation in the state, it can quickly recognize and reconcile it back to the canonical state in source control. Automatically apply approved changes in the system. Once you store the declared state in Git, you must allow all changes to that state to be applied automatically to your system through pull requests, PR, or merge requests, MR. You won't need cluster credentials to make changes to the system. There is also a segregated environment in Getups where the state definition lives outside. As a result, you can separate what you do and how you do it. What's excellent about Getups here is that it favors a low barrier of entry. In this case, you won't achieve immediate deployment or reconciliation until you achieve a new canonical state. Once you declare the state of your system and keep it under version control, you can use software agents to alert you whenever reality and your expectations don't match. Software agents also help ensure the whole system is self-healing to mitigate the risk of a human error and more. In this scenario, software agents act like an operational control and feedback loop. What is the role of infrastructure as code, IAC? Many Getups concepts and benefits are rooted in infrastructure as code. This also reflects a core foundational concept of Getups. However, to put it simply, Getups concentrates on automating tasks around Kubernetes clusters and deployments. Infrastructure as code essentially focuses on the underlying infrastructure, like everything Kubernetes clusters need to run smoothly. But this proves to be a challenge in the complete Getups model, as Getups processes aren't aware of the infrastructure. However, as most Getups adapters already have infrastructure as code skills, it hasn't become a significant issue. It can also take it a step further to ensure security by enforcing security standards as by using policy as code and security as code. This approach helps create developer-centric experiences with CD for cloud-native application. In this scenario, automated operators within a Kubernetes cluster of cloud infrastructure will be continuously monitoring the repository for change. Whenever it discovers a change, the operators will automatically trigger an update. You can also create a centralized playbook and enforce the proper workflows across the software development lifecycle. This approach helps development teams innovate faster without compromising security. You can also use this method to help ensure compliance. What are the key benefits of Getups adoption? Software developers often find a massive gap between the code they write and the idea that finally goes into production. We rarely develop applications in a vacuum, and there is a lot of source code management that takes place from day one. With Getups, you can take advantage of the following. Better ops. With Getups, you have a complete end-to-end pipeline. In this scenario, PR can drive your CI/CD pipelines and reproduce operations tasks through Git. Rapid development. When you adopt and follow Getups best practices, You must leverage tools like Git to quickly manage Kubernetes updates and features. When businesses continuously push features updates, they also become more agile. This makes it easier to respond to customer requests more rapidly and achieve a competitive advantage. Stronger security protocols guaranteed. As Git is backed by robust cryptography that helps track and manage change securely, your security is more or less guaranteed. In this case, the ability to sign change and prove authorship origin is crucial to secure and correct the definition of the desired state of a cluster. In the unfortunate event of a security incident, the immutable and auditable source of truths helps recreate a new system independently. This approach helps minimize downtime and sets the stage for much improved incident response. The separation of responsibility between packing and releasing software into production also helps ensure security. This approach follows the least privilege principle and minimizes the impact of a breach because of a smaller attack surface. Simple auditing and compliance. As we track and log change securely, auditing and ensuring compliance is a breeze. In this case, you can use a wide range of comparison tools like Ansible Diff and Kubediff to compare the trusted definition of the state of a cluster with a cluster running in the real world. This approach helps ensure the auditable and tracked change match reality. To tie this all together, Getups helps businesses with the internet at their foundation innovate faster and maintain a competitive advantage. In the digital age, only enterprises that can keep up with this relentless cycle will survive. At the same time, companies also need to leverage policy as code to ensure that their digital products remain secure. You just listened to the article titled Gitops 101. What is it all about? By Andrew Zola, published on CNCF blog. Andrew's article was comprehensive on the subject, covering the concept, the principles, the role of the infrastructure as code in Gitops, and the benefits of Gitops. I'm an advocate of the declarative system change approach versus the imperative one. So this is what I'm already sold on. And the rest of the principles sounded like an extension of that idea, which makes sense. One of the toolings which implement the Gitops philosophy is ArgoCD, and that's something I'm using nowadays. ArgoCD is a declarative Gitops continuous delivery tool for Kubernetes. Another one is Flux by Weaveworks, the creator of Gitops. You will find the links to the article, ArgoCD, and Flux in the description of this episode. Okay, now let's check the tool of today. Today's tool is Cubemonkey. Cubemonkey is an implementation of Netflix Chaos Monkey for Kubernetes clusters. It randomly deletes Kubernetes pods in the cluster, encouraging and validating the development of failure-resilient services. Check it out at github.com/asobti/cube-monkey. You can also check the description for the link. And so that's it for today. Have a great rest of your day, and I'll see you here in the next episode.